Hello everyone. So we were doing lesson number 2, that is your structure of atom, and in previous lectures we are done with your electromagnetic wave theory, which suggests us that your light is having a particle nature, and then after we are done with your photoelectric effect and your black body radiation, through which we come to know that light is having your particle nature. So Einstein in 1905 put forward a common idea that your electromagnetic radiations or light is having dual character, that in some cases it will behave as your as your wave, and in some cases your light will behave as particle. So this was his common observation, or this was his common idea. Now the topic for today's video is evidence for quantized electronic levels. That is, in this video we are going to discuss your atomic spectra. At what is atomic spectra? So basically your atomic spectra is of two types. One is your emission spectra, and another is your absorption spectra. We'll discuss one by one. Emission spectra, and second one is your absorption spectra. Absorption spectra. So what is spectra? Clear? We'll discuss all of them one by one. So we'll start with very first, that light rays are having very interesting properties. That is, when it propagates from one medium to another, it shows bending. This bending is dependent on frequency and wavelength. Clear? So more will be your frequency, more will be bending, and less will be your frequency, less will be bending. And we know your frequency and wavelength are inversely proportional to each other. So if your wavelength will be more, so bending will be less. Clear? For example, if we are having these two color radiations, and if we are passing them through a glass slab, then it is observed that when a light is passed through a prism or your glass slab, the wave with a shorter wavelength, that is your violet one is having shorter wavelength, and that's why it will show more bending. And the wave with your longer wavelength, that is your red, and this red will show less bending. So this is a common phenomena we observe when your light travels from one medium to another, and bending is dependent on frequency or wavelength. Clear? Now if we pass white light through a prism, then this white light will split into band of 7 color. It will split into 7 color. So this band of your 7 color is known as your spectrum. This band of 7 color is known as spectrum, and this is known as continuous spectrum. This band of 7 color is known as spectrum, and this spectrum is continuous because here if you'll see violet color merges into blue color, and if you'll see blue color, so your blue color is merges into next color. Clear? That is into green color, and so on. So here we can't differentiate from where it starts and from where it ends. Clear? So this is known as your continuous spectrum, where we are not having any bands, not having any lines. So this type of spectrum is known as This type of spectrum is known as your continuous spectrum. And the branch of science which deals with the study of spectra is known as spectroscopy. So the branch of science which deals with the study of spectra is known as spectroscopy, and the instrument with which we can separate different type of radiations of different wavelength is known as spectroscope. I am repeating it. The instrument which is used to separate the radiations of different wavelength is known as spectroscope. Now we'll discuss types of your atomic spectrum. That one is your emission spectrum, and another is your absorption spectrum. So next topic is emission spectrum. So emission spectra are obtained when radiations emitted from substance that have absorbed energy either by passing through electric discharge through a gas at low temperature or by heating your gas or any substance at high temperature, and it is analyzed with the help of your spectroscope. So atoms, molecules or ion that have absorbed radiation are said to be excited. Clear? For example, I'll take one example and I'll explain you. For example, this is your platinum rod, and this is having your hydrogen atom. This is having your hydrogen gas. Clear? This is containing your hydrogen gas, and you heat it strongly at high temperature. So what will happen? So when you'll heat, for example, this is your hydrogen atom. So when you'll heat your hydrogen atom, what will happen? The electron will get excited from lower, it will absorb energy and it will move to what? Higher energy state. It will absorb energy and it will move to higher energy state. And always remember, your electron always try to remain in what? Lowest energy. Not your electron, everything. Clear? To attain stability, जिसकी एनर्जी जितनी ज़्यादा होती है बच्चे वो उतना ही अनस्टेबल होता है. तो वैसे ही इलेक्ट्रॉन जब हायर एनर्जी स्टेट पे जाएगा, हायर एनर्जी लेवल पे जाएगा, तो आपके पास ये क्या हो जाएगा? अनस्टेबल. क्लियर? सो टू इन ऑर्डर टू अटेन व्हाट? स्टेबिलिटी, इलेक्ट्रॉन ऑलवेज ट्राई टू रिमेन इन व्हाट? लोअर एनर्जी स्टेट. Clear? So when this electron will return back to what? Lower energy state. Clear? Whenever your electrons try to return back to your what? Lower energy state, this energy. Clear? So the energy, because ये ऊपर से नीचे आ रहा है तो कुछ एनर्जी क्या करेगा? Emit करेगा. So this energy is emitted in the form of what? Radiations. This energy is emitted in the form of radiations, and when radiations emitted by different substances are analyzed, the spectrum is obtained, and this spectrum is known as what? Emission spectrum. Clear? So when an electron is excited to what? When electron will absorb energy, it will get excited to what? Higher energy level, and in order to remain in what? Lower energy state or in its lower energy, it will start emitting what? Radiations. Clear? So when these radiations are taken or analyzed in what? Photographic plate, so the spectrum we obtain is known as what? Your emission spectrum. Clear? For example, now this container is having, or this discharge tube is having atoms of any gas, and when we'll heat this container, what will happen? The electrons of atom will absorb energy and they will go to higher energy state. Now we know electrons always try to remain in a lowest energy level. So when electrons back, therefore energy emitted, and this energy is emitted in the form of radiations. Now when these radiations are passed through what? Are passed through prism, and when they are analyzed over your what? Screen or photographic plate, then we observe what? A pattern, colored bands, and this is known as what? Emission spectrum. क्लियर? तो इससे डाउट नहीं करना है कि एनर्जी एब्जॉर्ब करी तो एब्जॉर्प्शन स्पेक्ट्रम. नो, इट इज नॉट लाइक दैट. अगर आप किसी भी सब्सटेंस को हीट करते हो और हीट करने के बाद जब आप लोग स्पेक्ट्रा डिराइव करते हो, दैट विल बी ऑलवेज व्हाट? एमिशन स्पेक्ट्रम. क्लियर? सो एमिशन स्पेक्ट्रम आर ऑब्टेन्ड व्हेन द रेडिएशंस emitted from any substance that have absorbed energy are analyzed with the help of what? Spectroscope. So this is your emission spectrum. Clear? Now when we'll talk about your absorption spectrum, so your absorption spectrum is opposite of your what? Emission spectrum. Clear? I hope this is clear to you. So now we'll start with absorption spectrum and how absorption spectrum is obtained. So when a white light is passed through your any gas or through any solution of salt, and the transmitted light is analyzed, we obtained a spectrum. We obtained a spectrum over a screen in which dark lines are observed. If we'll observe this spectrum, then in this spectrum your dark lines are what? Observed. Now question arises, why these dark lines are observed? This is because when you are passing white light through this solution, then this solution or these atom will absorb energy of certain wavelength, or they absorb light of certain वेवलेंथ. अब जिस वेवलेंथ की लाइट इन्होंने एब्जॉर्ब कर ली होगी वो आपके पास क्या है, इस स्क्रीन पे दिखाई नहीं देंगे. फॉर एग्जाम्पल, इफ आई एम passing your what, passing a light and passing light through this solution, and this solution is absorbing light of your yellow color, blue color and green color. So when I'll obtain your spectra, then what I will observe that these three colors will be absent, clear, in your continuous spectrum. So this is your absorption spectrum. So in absorption spectrum you are having what? Certain dark bands, and always remember your absorption spectrum is always opposite to that of your what? Emission spectrum. I hope this is clear. Now here we are able to see the difference clearly. If we are having an excited sample, and if this excited sample is analyzed over your detector or your screen, what we observe here, we are having what? Your blue color, and these are certain what? Colorful bands. Clear, means these are what? Emitted radiations. जो radiations आपके पास इस excited sample ने क्या की हैं? Emit की हैं. अब emit वही radiations की होंगी जो ये क्या कर सकता है? Absorb कर सकता है, isn't it? ये excited sample है बच्चे. इसको जब हमने detector पे analyze किया तो हम लोगों ने देखा कि इसने ये जो आपके पास कलर दिखाई दे रहे हैं, इन रेडिएशंस की लाइट को क्या किया है? एमिट किया है. अब इन रेडिएशंस की लाइट को कब एमिट करेगा? जब इसने इन रेडिएशन की लाइट को क्या किया होगा? एब्जॉर्ब. अब हमें कैसे पता कि कौन सी रेडिएशंस को एब्जॉर्ब किया है? क्लियर. सो हमने क्या किया? वाइट लाइट ली और सेम सैंपल को यहाँ पे रखा. क्लियर. और जब हमने डिटेक्टर पे इसको चेक किया तो हमने देखा कि जो कलर यहाँ पे प्रेजेंट थे वो यहाँ पे क्या है? एब्सेंट. फॉर एग्जाम्पल, here we are having what? Blue color, but here blue color is what? Absent. This is because the blue color is absorbed by this sample. And here your green color is present, but here green color is absent. Here yellow color is present, here yellow color is absent. Why? Because this sample has absorbed these radiations, the radiations of these wavelength. So your emission spectrum is opposite to absorption spectrum, or absorption spectrum is opposite to emission spectrum. So this is all about your emission spectrum and absorption spectrum. Tomorrow we'll discuss about emission spectrum of hydrogen atom. Thank you.